Hi, welcome back. My name is Mathematics, and today we're going to learn how to multiply numbers which have a very special property. So let's take a look at some of these numbers. So what a number is going to look like that satisfies our property is it's going to be some digit, say 4, or some actually series of digits right here. And then we're going to have another digit, say 7. And now let's clear this and redo this. 4, 7. And now this digit right here, it's going to be the same. It's going to be another 4. And this one is going to be 3. So for example, 47 times 43. So I encourage you all to kind of see how would you multiply these two numbers. Well, most of you might go about it the straightforward way. You'd multiply 3 by 7, get 1, carry over the 2, etc. and kind of calculate that all. But there is a much faster way to do it. So here's what we're going to do. We're going to erase all of this and write these side by side. So we've got 47 and we've got 40, we've got 43, 43. And now we have these two numbers we're going to check. So this number right here and this number right here. And so we've got these two numbers which are pretty which have a really nice property. It's that they sum to 10. And this is really key because since they sum to 10, we can do this really cool trick. So first, you're going to want to take these two digits. They're 7 and 3. And we know that 7 plus 3 is equal to 10. So that's good. What we're going to do is we're going to take 7 and we're going to multiply it by 3 to get 21. And so let's write this in a different color here. We're going to put 21 in the side right here. So you've got 21 over there. And now, the next thing we're going to do is we're going to take a look at these digits right here. This digit. Now, remember, this digit right here, this digit right here, it should be the same right here. This digit right here should be the same as this digit right here. Now, if they're not the same, this trick doesn't work. So make sure that these are the same. We're going to take this digit. So say, in this example, the digit is 4. And so we're going to take 4, and we're going to multiply it by itself, rather square it. So 4 times 4. And this is going to equal 16. And the next thing you're going to want to do is just add 4 to 16, and that'll give you 20. So now if you take this number, we're just going to take this number, and we're going to move it right up here. And we get 2021. And that is our answer. So go ahead, calculate this out, or use a calculator, and you'll find out that 2021 is in fact the correct answer. So let's take a look at some other examples. One classic example is squaring a number ending in 5. And so if we try and do that, you'll notice, let's take 25. We're going to take 25 squared. With 25 squared, we have 25, 25, 5 plus 5, that's equal to 10, so that works out. 5 times 5, well, that's just going to be 25. And so we're going to take the 25, let's use blue. We're going to put the 25 right here as part of our final answer. And now the next thing we're going to do, we're going to take a look. We've got 2 right here. 2 is our leading digit. So we're going to say 2 times 2 is equal to 4. 4 plus 2 is equal to 6. So we put a 6 right here, 625. So now you might be wondering, what do we do if there's more than one leading digit? For example, 426 times 424. Now, what you can do is pretty much the exact same thing. You notice 6 plus 4 is equal to 10, so this works out. 6 times 4 is equal to 24. We're going to write down 24 right here. So we've got 24, and I'm not going to use a different color this time because you guys get the idea, but we're going to have 24 right here, and then we're going to take a look 42. Well, we've got to do 42 times 42. Now, for those of you who want to see us do it, we can quickly do it over the side here. 42 times 42. This is going to be 4, 8, 8, 16. This is 1, 7, 6, 4, 1764. This is going to equal 1764. Now, if we add 42 to this, we're going to get 6, 0, 8, 1, 180624. And let's make these a little bit bigger. We are going to get 180624. Just like that. And now if you were to take a calculator and calculate this out, you would do 426 times 424, 180624. Just like the answer that we got. So that's basically all you do to calculate the product of any two numbers which have their units digits summing to 10. So for a little bit of a mathematical intuition as to why this is true, suppose we got the first number is going to be a times 10 plus b. Now this is going to get into some algebra here, so if you aren't familiar with that, that's totally fine. This isn't really that big of a deal. And so let me just erase this and explain what I mean. So suppose our number is going to be denoted by some series of digits, which we're going to call A, and then the units digit B, times, again, some series of digits. These have to be the same, and then 10 minus B, right here. So the way we would represent this mathematically is A times 10, or a better way to represent it would be as 10A plus B, this, and then we're going to multiply this by 10a plus 10 minus b. And now if we're going to we can use the FOIL method, but it'll be a little hard, so let's do a different way. We'll say 100 a squared plus, so we've calculated that, plus 100 a, then minus 10ab, and then plus 10ab plus 10b minus b squared. So this is going to equal 100 a squared plus 100 a plus 10b minus b squared, right? And so now what we did is we calculated 10b times b, that's this right here. What we did, we calculated 10 minus b times b, we got this, and then we calculated a times a plus a. And a times a plus a is just a squared plus a. So this result is just 100 times a squared plus a plus 10 minus b times b. And those are the two things we calculated. The reasoning for the 100 is that, well, actually, we know that they're going to, their product, rather, is going to be a two-digit number, right? And that's just because we can have 9 times 2 is 18, and then 8 times 3, let me make this a little bit more clear, is equal to 24, and dot, dot, dot. You get the idea. It just gets a little, it gets higher and higher. And I accidentally messed up. This is supposed to be times 1 is equal to 09, and then times 2 is equal to 16. So this is actually a good place where I want to point out that you don't actually want to stick just directly in front of a 9. So for example, if you had 9 times 1, well, 9 plus 1 is 10. Great, that works out. You got 9 times 1 is 9. If you were to put the 9 and then 1 times 1 plus 1, that's 2, you'd get 29. Obviously, that's wrong. What it's actually supposed to be is 209. And that's because, remember, we need to have this extra 0. You need to make sure that it's 2 digits, not more, not less. Which is exactly why we've got the 100 here, to ensure we're not overlapping with those 2 digits. So that's a little bit of an intuition as to why this strategy works. But when you're actually calculating it all, you can skip all of this and just jump straight to this. It's much simpler and much faster. And it's a really neat trick for multiplying any digit numbers with units digits summing to 10. And so all it really ends up being is just a square plus a sum and then multiplying two one-digit numbers. So if you do know how to multiply squares together very quickly, this method will be very helpful for you. And if you don't, stay tuned for another video where I explain how you can calculate squares extremely quickly with any units digit. Thanks for watching, and I'll catch you in another video.